Disruptors and curious minds, CEOs, founders, book lovers. It's a Thinking on Paper book club. A book club as you have never experienced before. It is the second arch in the Thinking on Paper bridge of understanding technologies and their impact. We interview the CEOs, the founders, the outliers, and then we read books to go deeper. We're reading Space to Grow, Unlocking the Final Economic Frontier by Matthew Weinzierl and Brendan Rousseau, who hopefully will be on the show sooner rather than later.
Harvard guys.
And in part one, we learned about SpaceX, we learned about Blue Origin, we learned about how NASA gave the keys to the private industry, and the result of that is much cheaper launch costs, much cheaper access to space. But so what? Who cares? So what? So a bunch of billionaires can go into space for a little bit less than they used to be able to. So what? What does that mean for you? What does that mean for me? What do the skeptics have to say about it? And it's not an unreasonable question. And today we're going to find out, what is the value proposition of going into space? What's the point in going into space? What's the killer app? How do we make money? How do you make money? And specifically, we'll be looking at space stations and satellites. But Jeremy, first, before all that, I'm taking the cover and I'm throwing it away because I'm sitting in a broom cupboard and it's getting in the way. So
love it. No jacket required.
No jacket required at the Thinking on Paper book club. We're on chapter 4, Planet, Supply and Demand. What are your first thoughts?
First thing, disruptors and curious minds, and Mark, I need you to do me one favor before we get going. I need you to name my astronaut. Ready, you go. It's actually glow in the dark. I found it at a thrift store. It's pretty cool. What's the name?
I'm going to call your astronaut Alice, after Alice in Wonderland, and after my daughter, who I spoke to her about making money in space. And I said, Alice, there's a bit of a problem. There's a lot of people want to go to space, but nobody knows how to make any money when they get up there. And I was trying to use her childlike lateral thinking. Do you know what she said? You won't be able to guess what she said because you're an adult, but have a go. How do you make money in space?
I don't know. What did she say, Mark?
That's what you ask a 9-year-old. And she said, and I paraphrase, but she said, well, if nobody can make any money in space, Daddy, then just work for the aliens.
Ooh, man, such a great, open-minded, unconstrained, unencumbered answer to the question. Maybe that's it, because guess what? The U.S. has released all kinds of data that aliens are out there allegedly, and so we just need to find them and say, hey, what do your job postings look like in alien world?
Wouldn't that be really funny if like NASA spent all of this money and all this time encouraging the private sector to come and build spaceships and eventually build space stations and build all this infrastructure in space? And that's what finally got the aliens' attention. And they come in and they just take control and employ us all for UBI in space.
Maybe they're the real estate investment trust funds that are going to build the infrastructure of space. Well, let's get right into it. So Planet, chapter number 4, Planet references the company Planet, but also some other just ideas. And like you, Mark, so what is really interesting, right? I love to think big about tech, but there is like the so what piece, like why does it matter? And what are the big problems? And this is what I wrote down in my notes. I wrote, what is the product market fit for space economy? What is product market fit for these things, for launch, for orbital, for space stations, for all of that stuff? And it got us really into got me into an interesting mindset as we talk about some of the economics that they continue to reference, the principles that they continue to reference, the supply demand curves that they continue to reference. But that's where my head immediately went to.
The promise is hotels in space, mining asteroids for precious metals. You can understand why the vast majority of the population are skeptical about such claims when there is such a problem on Earth. And you're going to make money by building hotels really on the moon? I mean, there's a company doing it. Hopefully we'll have them.
GRU.
Yeah, GRU, can you do it? Well, it'd be interesting to find out. To quote from the book, the pursuit of space is inspiring, and inspiration can blind us to reality. Outside of a few obvious existing users, how could the rest of us and organizations benefit from lower costs to orbit? How much of what the optimists see as a potential of space will turn into reality? So we get into the first real use case. It's a company called Planet. It's about satellites. Satellites and the Le Chatelier principle, Jeremy. What do satellites and Le Chatelier principle have in common?
The company Planet and 3 ex-NASA engineers that decided they wanted to do bigger and better things, and do things that would, I don't know, that would be applied to the greater good. But yeah, let's break down Le Chatelier. The effects on the market, what shakes out in the short run is usually not as impactful as what happens in the long run. So as it applies to satellites getting imagery of the planet, when it first kind of happened, it wasn't like this grand explosion of demand that people are like, oh, wow, we can now see the Earth and do all these things, and the whole market just explodes. It's kind of more of a slow burn initially. And then the longer term effects, you have things other companies created. Those other companies create new initiatives. Those new initiatives inspire new market ideas. And maybe at some point people figure out, okay, well, maybe seeing the Earth from off the Earth has value and benefit.
You build something and it's not used very much by very many people at the beginning. People might think, well, what is this thing that you've built? It's not very useful. Okay, yeah, it's fun. You take the internet, it's got a few games on it. You can build your own website about your town and sell it for $100 million and build space rockets in 20 years' time. But it doesn't really do anything. And then you come back in 5, 10, 15 years, sometime later, and the thing that you built has suddenly taken on incredible meaning. There are many people using it. It has evolved. Things have emerged from it to make it different, to make it do more things. And so essentially you started out with something which didn't do very much, and now it does a lot.
It's a bit of a pushback on something that happens in the market. So like as I started like thinking through this, when you push back on a system, say, let's call the system exiting the terminal velocity of the Earth, launching off of it, right? And the effect on that system, efficiencies were introduced, launch costs were lowered, but immediately everyone wasn't going to space. Everyone wasn't going to the moon, but it sparked this longer term equilibrium or shift to equilibrium that we don't even know as of right now. Like Le Chatelier principle says, this is more of a long term. We may not know how the market organizes and shakes out, but whatever it does in the long term is going to be more impactful than what happens in the short term.
Yep. Quote, economists studying how companies can best respond to a fall in the cost of one of their inputs have found that the short-run response may be substantially smaller than the long-run response, a possibility they explain with reference to an idea from the natural sciences, the Le Chatelier principle. If we give the market some time to adjust, the demand curve may become less steep as companies rejigger their operations to make the most of the cheaper input costs. In other words, even if the demand response to lower cost seems limited today, we shouldn't simply extrapolate to the future. The short run might be a poor guide to the long run. And how many people have given up the race too early? Many. In many things. By the 1970s, Earth imaging satellites were turned to civilian purposes. Programs like the Landsat satellites, they were created by NASA and the US Geological Survey, and they provided systematic, repetitive observation of Earth's land areas. The wealth of data was incredible. It allowed us to look at physical, chemical, biological variables, of course, weather, natural disasters, climate change. But the Landsat satellites were mega expensive. They only really were used by the American government and then later on mega tech giants. And Planet, founded by Will Marshall, Robbie Schingler, and Chris Boshusian, all NASA engineers, thought that they could do it quicker, better, and cheaper, way quicker, better, and cheaper by making the satellites really small.
Well, making them really small and building them out of cheap pieces and parts. So they started making satellites out of laptop batteries, cell phone grade semiconductors, motors, accelerometers. Quote, nothing was pre-qualified to be in space. We bought most of our parts online, putting our terrestrial and orbital economies onto the same clock. So the things that we used to build to put up in space were very expensive, took a really long time, and they did because they wanted to make sure they worked when they got up there, right? But now launch costs are down. We're able to throw more experimental things up there, and we're able to match the components and build them quicker because we can grab off the shelf. That way the computers aren't 8 years old. They're 6 months old, I think is a reference in the book.
Was it Landsat was a handful of satellites? They wanted to put 150 satellites up. And so they borrowed from the playbook agile manufacturing. Like SpaceX, Planet emphasized rapid iteration and making small improvements to every spacecraft design to produce an evolution of capabilities over successive generations. Central to this approach was an emphasis on smaller, less complex satellites. Why did it take a small private company called Planet with 3x NASA engineers? Why did it take them to come up with the idea of why don't we just make the satellites smaller?
I think it's a launch cost thing, and I think it's a risk aversion that large government entities tend to have. They're less nimble. They're tied to different funding mechanics, just the availability of pieces and parts, and hey, we don't care. This thing only costs a fraction of Landsat. So if it gets up there and it doesn't work, we've learned a lesson. We could do better on the next one, and it's not a completely sunk cost, right? So what do these doves do, Mark? What are these? They call them doves, these satellites, this constellation of Earth imaging satellites. What do they do, Mark?
If you've got one satellite in space, it takes a long time to go around the Earth to orbit, and to go to the same place takes even longer. If you have this mesh of smaller satellites, you can monitor what's going on in almost real time. So Planet, they gathered low resolution continuous image of all the Earth's surface, higher resolution imagery for specific locations up to 10 times per day, and an archive of thousands of images for each point on the Earth that Planet satellites had captured over the previous decade. Together, Planet satellites gathered over 30 terabytes of new imagery daily, processed and scrutinized by the company's machine learning algorithms. By 2017, Doves achieved nearly daily coverage of the Earth. They could monitor the climate, they could monitor destruction of the rainforest, how much land is being burnt, how much land is being farmed, how much land is being turned over to agriculture. What did the book call it? A real-time accounting system of the Earth.
I like that. Yeah, and then also the reference to the war in Ukraine has shown the commercial satellite data can make a decisive difference, informing both military planning as well as a public view of the war. This was Mariel Borowitz, a remote sensing expert and Georgia Tech professor, saying that conflict, the war in Ukraine, could be an inflection point for Earth's imaging sector, right? So what can be done with this information?
It was Planet's doves that first saw the buildup of Russian troops on the border before the invasion. That's how the world learned about what was the plans of Russia back at the beginning, just before the war started. So skeptics pointed out that as inspiring as Planet's story might be, its long-term success as a business was still far from guaranteed. I'd also add another skeptical view on that. I'm good at these. It sounds like a data collection agency. It sounds like they're collecting data of our every movement on Earth. It sounds like in the wrong hands, there is a lot of data collected there. And if you're a skeptic, so why would I want to encourage this kind of behavior? Big tech is essentially a machine, a data harvesting machine. Why do you want to take that up into space? So yes, the business case might not work, but also the moral, human, individual success doesn't really always correspond with how the skeptic views. Yeah, what do you say to that, Jeremy?
That's a great question to put on the docket for our second interview with Carissa Velez, because I think she'd probably have a lot of points on that.
And Metzger, and Philip Metzger, we should ask him how he wrestles with this as well.
100%. Really good point. Yeah. So technology gets developed by these big companies. They figure out ways to monetize it. Usually the way they monetize it is by our data. It's what's been happening for the last decade or more, right? And what if technology could build things on the opposite side of that, that, could build something that scrambles the view of my house from a satellite. And I have maybe a permission flip that I could say, no, I'm okay with you guys. We're in a rough situation. There's a war right down the road. Maybe I might want, to help out with that cause. Right. But I don't know. The tech has got to be used and harnessed by people to protect themselves from the tech that's out there taking your data. Right.
Because that doesn't sell. So who is buying the information from Planet? How did Planet become a money-making company? Governments.
Defense contracts. Yeah.
Defense contracts and governments buying their data.
I mean, it's how the internet started. Yeah.
It didn't start with that much data. It didn't start with
by a defense contract. By a defense contract. Yeah.
Yeah, true. Okay. So a problem with the space industry is that who is the customer? The customer is essentially governments at the moment. And they get into subsidies and how the subsidies affect the economics of space. And if the government are subsidizing these build outs, great, it all works. But then the governments are subsidizing these build outs, and then they are the customer at the end of it as well.
Well, let's keep as we have the pendulum, the doom utopia pendulum,
swinging,
kind of bringing it back to the utopia side. There's always an interesting call to action from the author that's kind of like, hey, think about how you could use this stuff. I was in the car today for about an hour, and I was like, how could I use Earth imaging data? Like, how could you? I don't know. I didn't land on anything in like 45 minutes. It was really annoying.
Climate change. If the climate crisis, perhaps these satellites, perhaps this imagery, perhaps this data, when it's fed into an LLM, they pick up the patterns. They see the pixels that are changes that we don't. They can see those changes in the ice flows. They can see those changes in the water levels, in the water temperatures. They see something. And maybe it takes that kind of knowledge that eventually it gets drilled into the people who make decisions. Here's the data. It's irrefutable. We're screwing things up. We got to change it. We've got to stop making promises, stop saying things, and actually act. Then maybe that's the.
How are these pixels going to be any different than shit that's been living in research papers for 15 years?
Because the LLMs will be analyzing the pixels. As an aside, so there was this funny thing, there's a story not related to this at all, but about pixels in the Italian Alps. A climber went missing last year, presumed dead. They couldn't find him. The spring came. They sent out the helicopters. They sent out the mountain rescue. They searched and they searched. They searched. They couldn't find it. They used drones to take image of the whole mountain. They fed the images into an LLM. The LLM looks at the individual pixels on these images, found one pixel that was the wrong color, or it thought was the wrong color, didn't fit the pattern of the surrounding area, and it was the missing climber's body that they found, which they wouldn't have found without it. So that pattern recognition, I don't know, Jeremy, it's all pattern recognition.
Yeah.
What about space stations? Moving on.
All right, I want to start this section with something really, really cool. I think Reagan was in office when the ISS was announced, if I'm not mistaken. And it's kind of this, not quite Apollo moment, but this continuation of the shuttle piece, and hey, we're still doing stuff. But ironically, a Republican had enough of the spending that was going on in the space station and organized a proposal to basically shut it all down. So June 22nd, 1993, they're voting on, do we keep the ISS, up or down? Do we keep the ISS, or is it done? There was one congressman that basically saved the ISS. And this congressman is actually amazing for way many more things than saving the ISS. This congressman nearly died in Selma, Alabama in 1963, causing what he called good trouble, which is a philosophy that I love and believe in as someone from Atlanta. And this gentleman is John Lewis, the civil rights activist icon, famous for a number of things, almost died in Selma. If he died in 1963, we may not have something sitting up in space. Here's a quote from John Lewis. I still believe, as do the majority of the American people, that it is America's destiny to explore space, not for the Cold War reasoning of proving we are the greatest nation on Earth, but because we are the greatest nation on Earth. John Lewis, save the ISS.
Mic drop. Let's just take a moment. So, space stations. That's no space station. If stations were cheap and easy to use, there would be no shortage of visionaries and entrepreneurs eager to try out their ideas on them. Beyond R&D and manufacturing, there's tourism, a market already generating revenue, even though today's space tourists have almost nowhere to go, except up. They go up, don't they? Looking further ahead, if we start harvesting resources from asteroids or the moon, or harnessing solar power from space, all of which we have gone into in depth on Thinking on Paper, by the way, space stations could be both where we manufacture rocket fuel, satellites, and spacecraft, allowing us to avoid the costs of getting them into orbit, and also the platforms from which we service space infrastructure and ship exports from space to Earth. Space stations are a good idea. The problem is, they're just so bloody expensive.
Yeah, it's hard to generate revenue on them or with them, even though you sponsor launch costs and research experiments and all that. But guess what? Page 108, who is referenced but our friend Gerard O'Neill in the spinning colonies, right? So that it's 6 degrees of Gerard O'Neill in our exploration of space. So let's talk through space stations and the history. So NASA first started space stations in 1973 with the launch of Skylab, small little station, 3 astronauts, kind of on the heels of, quote, on the heels of the moon landings. The agency was especially interested in learning how longer stays in the harsh space environment affect human health. So a couple of missions, 6 years of operation, and the budgets kind of got a little tight. Fast forward a bit. Was there anything between Skylab and ISS? I don't think so.
No, I was just looking at the Ronald
Reagan. It just
Reagan
took a minute.
Quote. How did Ronald Reagan speak? Just as the oceans opened up a new world for clipper ships and Yankee traders, space holds enormous potential for commerce today. Carl Sagan was against space stations.
Dyson was too.
Yeah. The scientific justification for the space station, concluded famed astronomer Carl Sagan, was illusory.
What was his step, I wonder? What did he think was the next step? Moon? How does he see his pale blue dot if we don't have something to look back from?
Maybe he'd spent too much time thinking beyond. Maybe he thought, maybe terraforming. So in 1998, 5 years after securing the ISS, in 1998, 5 years after securing the ISS's authorization by only a single vote in Congress, as mentioned by Jeremy, NASA began launching what would become a large, complex, and costly station. The completed ISS included 16 connected modules, was larger than the biggest aircraft in the world, and weighed in at nearly 1 million pounds. Inside, it had as much living space as the cabin of a 747 aircraft, enough for 7 astronauts. It cost $4 billion in annual upkeep on top of the estimated $100 billion for initial construction, which meant that it and the vehicles to supply it absorbed roughly half of NASA's annual budget. That's why there aren't many space stations.
So I wrote down this question. What activities in space actually require a permanent destination? There's a study in 1985 that predicted the pharmaceutical industry in orbit to be potentially by 2025, I think, to be $20 billion. That didn't happen.
Didn't happen.
So where's the...
Well, was that an economics thing? Was that to do with subsidies and so just
launch costs too?
Yeah. Just back on your microgravity, it's not because gravity is so much weaker in orbit a common misconception. Earth's gravity is still 90% as strong at the ISS's altitude as it is on the Earth's surface. So I didn't know that. Microgravity removes convection, sedimentation, and buoyancy that warp and disrupt physical and chemical processes. In microgravity, Diffusion is the dominant process, a gentler mixing that enables more perfect, uniform, and precise structures at the level of individual molecules and groups of atoms, leading to unique alloys and formulations. But that's short-term incentives again, isn't it? Who wants to go spend all that money to go into space to experiment with perhaps making new materials when there's so much money to be made down on Earth?
Right.
With existing materials. It's incentives, and it's short-term incentives.
Yeah, all of this stuff is really cool and down the road game changing, but like it's really tough to get people to throw money into it because nothing is really going to come out of it except more cool experiments in the next few years. And you got to have some patient money or billionaires to make some of that stuff happen.
So NASA have learned, haven't they, that after the COTS experiment in getting launch costs down, they launched a new experiment. By the late 2010s, the ISS was beginning to age, and lawmakers made a crucial decision. It would be the last US government-led destination in LEO. Instead of building and operating a space station itself, NASA was tasked with supporting the creation of commercial stations. What did they launch? What was the name of their...
CLD, Commercial LEO Destinations, which is basically the space station version of COTS and Commercial Cargo and Crew that was so successful. This was pushed out in 2021, $415 million. The outcome had something called Skylab pop out, Orbital Reef, which was a Northrop Grumman thing. Hilton Hotels actually signed on to help the Skylab team design the stations. But guess what? Didn't really happen, did it?
No. Well, so was that the one where there was an inflatable, the best where was it about the inflatable module for the space?
There were two.
There's actually one up there now, an inflatable module on the space station.
How would you feel about that? Like sitting in a tent in outer space with nothing but, I don't even know what the...
But they skipped over that bit, but it's true. I've just been thinking about this inflatable module that's joined to the space station now that people are in and using.
Well, that inflatable model was worked on for 20 years and at $250 million by someone called Bigelow Airspace. Basically took the IP from NASA when NASA wrapped up what they called Transhab.
Bigelow saw itself as the beginning of a low-cost inflatable commercial space station revolution. Its giant marshmallows could offer countries and companies the benefits of microgravity at a bargain. I laugh, but it's up there. There's two parts to wrap up this chapter, really. Like they ask the question, is there a market? Is there really a market for space stations? And then they lead on to the chicken and the egg scenario, whereby, build it and the business will come rather than using the business to build it. Is there a market? An in-depth study in 2017 by the Science and Technology Policy Institute identified many potential revenue-generating activities within the next decade, which, if they came to fruition, would present a total addressable market between $450 million and $1.2 billion. However, the study also found that the station's costs were likely between $460 million and $2.25 billion. Overall, our analysis showed that it is unlikely that a commercial space station would be economically viable by 2025.
Well, here we are. Do you see any commercial space stations up there? I thought something was really pretty funny. They were talking about this like shopping mall analogy where you have the anchor tenant and then you have the non-anchor. You have the Riches or Macy's anchor tenant, and then you have your I don't know, name a mall store that comes in, right? So the mall store is like, oh, we can pull from the traffic from Riches and Macy's. But I started thinking, like, we're just applying a terrestrial format to space. Like, this got to be a new format. It's got to be like a new way to think about the logistics, the economics, all of that stuff. There's got to be some big time innovation and thought on how to apply this and say, okay, so what? What do we do with it? And then how do we use that to scale the next thing and the next mission? And I don't know why we just don't follow this damn footprint. Why we just don't get the, like, if we had the space-based solar power up a long time ago, we're making money. Gerard O'Neill, we flip up some colonies, and then we start living up there. Then we start making things. And then Mark jumps on the moon. He figures out how to get the mass driver working. Yeah, it's my solution. All right, let's land the satellite, Mark.
space to grow without a dust jacket now, so I can't actually show up the picture and kind of. Ooh,
I'm so excited that you took your dust jacket off. Like that
Only
literally
feels
makes
great.
my Friday. Makes my Friday.
Space to grow. Great book, really like it. I'm looking forward to learning about astroscale and Artemis, more details about Artemis. I'm looking forward to that, about capital, who's spending it, where it's coming from. I'm looking forward to bring it all together, connecting it, and to see where NASA and SpaceX and Blue Origin and space-based solar power and orbital hotels and hotels on the moon all fit together in the thinking on paper ecosystem.
Hey, P.S. Alice behind me, Alice the astronaut behind me says, get space into your thinking. Entrepreneurs, this is the call to action. This is these two gentlemen saying, learn about this, identify the gaps, find your opportunity, and help fund the future
Of space. Stay disruptive. Be curious.
Keep thinking on paper.